Hey everyone, how are you doing? Take a look. We have a little board here from the Xbox One Model S. Okay. Before I explain what we are going to do here, even though the image is already showing a lot, I always want to remind you about our protective gloves, right? We're going to work on the motherboard, so protect your hands with a glove, an anti-static glove. It can be a pharmacy glove. I like these pharmacy gloves here because they fit better. It still bothers me a little to work, but less than the other one there. And it's important that we use it, okay? Our workbench here is also covered with static butter. So take these precautions, okay? What are we going to do today? The multimeter is already beeping there. What are we going to do today? This board here has a short circuit in the main power line. In other words, a short in the 12-volt line. Right. We are going to identify this short circuit here. And we will start from the principle that the first thing we will do based on experience is to look for this short circuit, where it usually occurs, where it occurs most often. Of course, at some other times you will encounter a short in a different location. But it is important that we always start with our logic, right? Let's start with where the short circuit is usually located. So we will begin today by taking a look at this VRM. Okay, VRM is the power section here for the processor, right? Whenever you hear or read about VRM, you should know that it is a processor power line. Next here. In this line, it didn't turn off. Again here in this line. In the processor power line, we have 3 high-side MOSFETs and 3 low-side MOSFETs. The MOSFETs that are directly connected to the main power line are the high MOSFETs. So, here are the smaller MOSFETs. There is one here as well that goes to the memory area. There is another one further down on the board here. But for now, we will work on the VRM because this is usually where the problem is being generated. Due to its high power operation, the tendency is that it will encounter problems before the others. Here, let me measure for you so you can see that we really have a short circuit. I'm going to take this. I'm going to take a little capacitor here. Do you see there on the multimeter? It shows a short. I'm going to take it from the other side of the capacitor. You will also show me why it is the GND, right? Let's take a look at the power supply connector. There is a short circuit in the main power line. So, what can I do? I can start removing one by one of these high MOSFETs to see if the short disappears. I can start removing the capacitors to see if the short circuit goes away, or if the short circuit goes away, or the controllers. However, before doing that, in some cases we have to do this. Okay. But before we start randomly removing components here, let's do some tests on the high MOSFETs. We have here to see if we have any indication of one that isn't working properly. Okay. Here we are going to do a basic test just to see if we can identify the MOSFET that is shorted, which is causing this problem, right? In some cases, when I don't have a short circuit on the board, this component doesn't always short out, okay? Because when it shorts, the entire line shorts. So I know that I have a short and that something there is shorted, but it doesn't always short. Sometimes the component simply burns out. Sometimes it simply burns out. It won't disrupt the circuit, but it won't perform the function. It should, meaning the game won't work as well. In these cases, we will take a look at the MOSFET tests. We are going to take the MOSFET and see how we can test it. Continuity test. Test to see if the MOSFET is turning on. If it is not turning on, basically. This type of MOSFET receives a pulse at the gate and activates the continuity between drain and source. So we will need to do a test at another time to learn how to turn on the MOSFET and see if it is working properly, if it is turning on and off. Right? Today we want to identify a short circuit. So, what are we going to do? Let's start by taking some basic measurements here on the high MOSFETs. what am I going to do here? I'm going to take the black probe of the multimeter. Let me take care here so I don't block your view. I'm going to connect it to the gate. The gate is pin 1 of the MOSFET, right? Looking at the MOSFET here, in the position it is in, it's the first pin on the left, right? This is the gate. We have the pin on the gate. Let's place the red probe on the SRS. Instead of putting it on his leg here, which I can also do, I will place it here on this resistor. This resistor here is the output of the SRS and goes to this resistor, which makes measurement easier. Alright. We have a resistance of 674 ohms. Apparently it's okay. Let's move on to the next one. Same thing. Black probe on the gate. Red probe is a Circe. Oops, I don't think I got it right. Come on, come on, come on, we can do it. There. See, the resistance is a little low. Okay, 500, okay? 511. Alright, let's move on to the next one. Let's see the next one. Next, oh, it's even a bit chipped around. Maybe that's some indication, okay? Same thing. Black probe on the gate. Red probe on the source. Here I have a resistance of 672 ohms, very similar to the resistance I had on the first high MOSFET. This allows us to understand that the one in the middle here is a little lower. It's a bit altered, right? Do you notice? Here I have 672 ohms. There in the first measurement we did, we have 673 ohms. Very similar. And this one in the middle here, the second MOSFET, we have, let's go. Let's take it. We have 501 ohms. You notice that this is different, right? Now we are going to do it differently. We are going to reverse the probes, so I will place the red probe on the gate. Let's see if I'm not covering anything here. Red probe on the gate. Black probe on the source. My multimeter doesn't go to 0L. It shows this very high resistance, which means it's okay. Everything is fine. Let's go to the second one here. Red probe now on the gate. Black probe on the source. This is wrong. This cannot be. There cannot be this lower resistance from 4.5 to 6.5. Right. Basically, with the black probe on the gate and the red one on the source, it conducts. It has a resistance. But with the red probe on the gate and the black one on the source, no. Let's move on to the last one here. Red on the gate, black on the source. This very high resistance that is showing up there indicates as if it were 0L. The 0L just appeared there now. That's it. So you notice that the first MOSFET here and the last one show me a pattern. Right. The one that deviates from the standard is this central MOSFET here. Let's go over it again. Red probe on the gate, black on the source. Let's go for it. It's hard to reach here. I'm far away. So I got it. 4, 6, 7, 11. This here is wrong. It can't be. Let's reverse the probes like we did in the first tests. Black probe on the gate and red on the source. You see that it is conducting from both sides, right? So we already know that this MOSFET here is not good. There may be something else. Is it causing a short circuit? It could be, it might be. But initially we already know that this guy here is not good, so we are going to remove it, right? So, what am I going to do now? This is for you to understand well, okay? We are going to do these basic tests that help you when identifying the component, so you don't have to go removing everyone. If you take them out one by one, testing until the short disappears, it will work too, okay? But by doing these tests, you avoid having to remove everything. So what we are going to do, okay? We are going to remove this guy here now. I will take a little pause here, alright? I won't film the removal. I will simply apply some flux here with hot air and take it out. I bring the board back here to measure if the short circuit is gone. If the short is gone, I will pause again, go over there, put the other one of these in place, and then we will come here and test if the game will work, if it will turn on, right? It could be, remembering that there might be something else here, another type of problem. But the first step we need to take now is to remove this guy here and see if the body has disappeared. Right. I'm going to go remove this MOSFET and I'll be right back with you. Okay? All right, we're back. I removed the component. The station is still on. I took out that MOSFET. Besides that, I removed the high MOSFET that was there with a modification. Now let's measure if we still have our short circuit in the main power line. I will place the multimeter probe on the connector. And look at the multimeter. Where's our short? There's no more short, right? In other words, it really was that MOSFET that was shorting, the one where we found an alteration. You see that this is a very basic, very simple test. It helps us a lot to find the defect here, but it is really a very basic test. The MOSFET test is more than that. For example, in some cases you won't find a short circuit here, but the MOSFET is not turning on, for instance. Here we have a controller that sends a pulse to the gate and activates this MOSFET to allow voltage to pass between Drano and Cersei. There is a function to turn the MOSFET on and a function to turn it off. We will have a class about this, about testing MOSFETs, among other things. So there we will see it very clearly. But here in practice, I wanted to show you how relatively simple it is to come and take some measurements here and go directly to the component. So you don't have to start removing everything, right? For example, if I were to start removing things here, I would probably begin by taking this one out. Because we notice that there is a little peeling in the varnish around it, so we kind of go with that intuition. There's a greater chance it's this guy. I was going to take this guy out and it wasn't going to happen. I was going to the next one, probably on the second attempt, I would manage to do it. In some cases, it's here, capacitor. Sometimes it's not even the MOSFET. Sometimes it's a capacitor that has shorted, right? But with these basic tests, we can already find the component without having to mess with everyone. Let's test the pins of the source again here and take a look at the multimeter. Very high resistance, meaning we no longer have a short circuit in the line. What am I going to do now? Now I'm going to do the following. I'm going to pause, okay? I'm going to put another MOSFET in place, and I'm going to put the heatsink here so we can do a basic test on this game to see if it will turn on or stay on, okay? To check if it will display everything is fine. Now I'm going to change the position of the camera here so we can see it. All right, okay, we'll be right back. Hey everyone, I'm back. So before I assemble this here, I placed a new MOSFET here. Before we put on the heatsink and assemble it here for testing, okay, to see if the game will stay on, I decided to come back here just to take that measurement again. Okay, so here's the thing. I'm going to, the MOSFET that we replaced, I'm going to take the gate with the black probe and the source with the red one. Let me set it to the right scale here. Notice that now I have 640 ohms, which is a resistance very similar to what I had before. Right. With the others, right? Now I'm going to reverse the probes. Let's go. Put the red probe on the gate. I'm going to put it in the SERS. All right, let's go for it. Let's see if it works out. You notice that he is already going to give me that very high resistance that I have in the others. That's right. The resistance is already quite high like I had in the others, right? So you can see that that MOSFET was indeed faulty. I replaced it, but I haven't tested it yet. Let's test it now. It's actually a little warm here. That's why the resistance was a bit lower in the test. So let's go. Let's plug in our heatsink here. I'm not even going to change the thermal paste. This board still needs to be cleaned. Then we do that later. This is just to see if it will work, right? If it will stay on. We don't have any short circuits anymore. Let's go. Let's assemble our game here just to be able to turn it on. Let's see if it holds up, right? Put in the HD. Let's plug in the HDMI here. Turn on the power supply. Let's go. Let's do a little test there. Turn it on. It turned on. Let's see the TV. The TV signaled. That's it. Beautiful thing. Let me show you here. It's still on. I'm going to move the camera here, okay? But it's just so we can look at the TV over there. Look there. Look right there. There it is. Cute. You notice that we had a short in the main power line. The problem was really there in that MOSFET. We did some basic tests and went straight to the MOSFET that was having issues. There you go. Our video game is fixed. It's taking a little while to get to this screen maybe because of the HD, right? When it had that short circuit, it shut down abruptly. The game may have corrupted something, but there it is. It's working nicely. Alright, here it shakes a lot. Okay? You can move the camera this way and that way. So you notice that this board has already been to another place, right? And there are a lot of good technical support options out there. Now this type of technical defect needs to be resolved. This kind of defect must be fixed. It's not complicated to find a short like this. You just need to know how to handle it. Now another type of defect, for example. If I need to replace a chipset or do a reball on the PU, that's fine. But there are people who don't work with reballing. So that's okay. However, a short like this needs to be found. There's no justification for not doing it. Technical support has to find this type of defect. Those who already work with this know that it is a pleasant defect to work on and relatively easy, right? Guys, I've already gone on too long here. This lesson will require a lot of editing because I included 2 recordings, 2 cameras. So, I'm going to prepare this here. I hope it has been clear to you how not difficult it is for us to look for a shorted component and troubleshoot it in these cases. So I thank all of you for your attention and see you next time.